welcome to Science Fools. It is me, Dr. Claire, joined by Dr. Blake,
Dr. Mary Faith.
Today we are focusing on physics, and we're going to teach you all about the force.
May the force be with you.
If you think mass and weight are the same thing, then you are definitely thinking wrong. Mass is the amount of space an object occupies, while weight is the Earth's gravitational pull on you. This is calculated by multiplying the acceleration due to gravity, which is about 10 meters per second squared, by your mass. Remember, these are two completely different things. Think, if you are in a gravity-free environment, there are no forces acting on you. This example shows how it is easier to walk because there are no forces acting on you. In this example, gravity is acting on you and it pulls you down to the earth.
Acceleration is the rate of change in which something speeds up or slows down.
I just wanna run, hide it away, run because they're chasing me down. I just wanna run, throw it away, run before they're finding me out. I just wanna run. I just wanna run, I'm not here all alone. I try to call your house, can't reach you on the phone. I'll gather up enough, I'm packing up my bag. It's more than you deserve, don't treat me like a drag. I'm feeling like
Have you ever heard about Newton's first law of motion? It states that an object in motion will stay in motion, that is, like keep on going, and an object at rest will stay at rest or stay still unless acted on by an unbalanced force. So that's like a push, pull, something that like makes the motion like move or stop. So, for example, if I were to drive this car, gotta put your seatbelts on. So I would go, and if all of a sudden a deer came out in front of me and I slammed on my brakes, since the car was still moving, and since I was on the car, I was still moving, and I suddenly stopped on the brakes, which was the unbalanced force in this case, I kept accelerating because nothing stopped me. However, since I wore my seatbelt stopped me, and I stayed safe. Newton's first law can be seen everywhere. For example, when you throw a snowball, since it's in motion, it will stay in motion. However, as soon as it hits the person's face, it will stop with the force.
Newton's second law states that force is directly proportional to acceleration, while mass is inversely proportional to acceleration. This is represented by force equals mass times acceleration. First example, there's less mass, so the acceleration speeds up, as in the second one, there's more mass, so the acceleration is less, even though there is the same amount of force. This video shows that when the force increases, the acceleration of the snowball increases as well.
Let's learn about Newton's third law. This law states that for every action force, there is an equal and opposite reaction force. We use this law in our everyday lives. For example, I'm going to high-five my little sister with an action force. She's going to respond by hitting me with an equal and opposite reaction force. If an object is on a table, then there is a force acting on it that opposes gravity. This is called the support force. The support force resists gravity, and if it equals the force of gravity, an object will not move. For example, let's look at a cheerleading pyramid. If you think of a cheerleading pyramid as an example of a support force, then the bottom row would be considered the support force, while the person on top is the object. In this case, the bottom row has an equal force to that of gravity and holds the top person up. However, as soon as the support force leaves or is not strong enough to gravity, the object is immediately pulled by gravity and goes to the ground. If the support force is greater than the force of gravity, then the object will go flying.
Have you
Ever wanted to go bungee jumping? And have you ever wondered how that works?
Look up, look at that bridge. And here we go. 3, 2, 1. Oh yeah, cheers, bud. Yeah, mate.
Got 7 on there.
This is called a tension force. It connects the force of something with an object. In this case, the bungee cord pulls equally on the bridge as it does Dr. Blake.
Have you ever heard of friction? Friction is what friction opposes motion, and it's like what makes an object like not be able to move. So, for an example, if I were to put Sheepy on this chair that has very little friction on the surface, Sheepy will fall. However, if I put Sheepy on a chair that has a surface with more friction, Sheepy will not fall.
Friction forces include static and kinetic forces. Static is when the friction force is greater than the force used to move an object and doesn't allow the object to move. Kinetic friction is when the force of friction is less than the friction force used to move an object and acts on the object while it is moving. It is harder for an object to overcome static friction than it is to overcome kinetic friction because the coefficient of friction is greater for static friction than kinetic friction.
The friction's too great for me to move.
They see me rolling, they hating, controlling and trying to catch me riding dirty.
The coefficient of friction is the ratio between two surfaces involving friction. In these examples, the object was pushed with the same force, but the surfaces had different coefficients of friction. The higher the coefficient of friction, the more force you need to get the object moving.
Now let's learn about centripetal forces. Centripetal forces are what allow an object to move in a circular motion. So for example, we'll take Sheepy here and attach him to a leash. Do not try this at home. So as I move in a circle, Sheepy stays in this circle because of centripetal forces. The forces in this is the tension force that allows the sheep from it's like this basically the support force.
Our last segment deals with equilibrium. This happens when all the forces acting on an object are balanced. Static equilibrium is when an object is at rest, shown with when the fan is not moving. But then, kinetic equilibrium is when an object is at a constant speed, but the net force is still zero because all the forces are balanced.
Thank you for joining us today in Science Fools. I hope you enjoyed this segment on forces. Join us next week.